Now, so girls, we're looking at exercise 7H, the cosine rule, okay? So, we can use the cosine rule to find an angle or a side. Same with the sine rule. There are two versions of it. The thing with the cosine rule is that it relates one angle and three sides of any triangle. Now, how do we know that? If you look at the formula, remember that lowercase are side lengths and uppercase are angles. This is to find the side. See the subject of the formula, which is the pronumeral at the front, is a small a. That is a side length. So to find little a, this little a here, for example, you do little b, so a squared is b squared. So this side squared is b squared plus c squared minus 2 times b times c times the cos of capital A. Notice when you're finding little a, you do cos of capital A. All right, so what we're going to do, we're going to write the formula out to find little a, little b, little c. So if you can write the first line, so the cosine rule relates one angle and any three sides, you can write out the first rule there, but what I'm going to do after that, we're going to write this rule 3 times with a out the front first, then with b out as the subject, and then with c as the subject. See if you can see the pattern in the formula. So let's start writing. Okay, cosine rule. It relates one angle and any three sides of a triangle. When finding the third side of the triangle, given two sides and an included angle, you will use the following. Now I'll draw a little triangle over here. I've got capital A, capital B, capital C, little a, little b, little c. Remember they're opposite each other. You go a squared is equal to b squared plus c squared minus 2bc cos A. So this is what I say. I say a squared is the other two sides squared, right? So if you want this one, you have to know the angle opposite it, right? So a squared, if you want this one, it's the other two sides squared, right? Minus 2 times those two times the cos of the one in between. Again, it says when finding the third side, you have to be given two sides and an included angle. What is in this formula? If you want A, listening, if you want A, what's in the formula? Read them out. B, that one. What else is in the formula? C, what else is in the formula? BC, and cos of capital A. So if you want to find a side length, I've just circled what you need. The other two sides and the angle between them. That is called two sides and the included angle. Those two sides, included angle is the angle between them. So if you want a side length, like side A, you need the other two sides and the angle in between them. Not the other two sides and some other angle. All right, can you see you need little b, little c, little b, little c, and capital A. Capital A happens to be located between little b, little c. Does that make sense? So girls, when finding the third side using the cosine rule, you must be given, you must be given two sides and an included angle. That's one version of the formula. What happens if I was finding b squared? Look at this. If you want a squared, you write the other two down. So what do I write here? B squared equals a squared plus c squared minus, well, the same ones again, 2ac cos, see, little a, capital A, little b, cos of capital B. Got the idea? What would be the formula for c squared? So this is how you're going to be given the formula, girls. You get given the formula. C squared is the other two squared, a squared plus b squared minus 2ab cos of c. Now, let's look at the formulas. If you want b squared, notice you need a, the other two sides, and the included angle. So if you want little b, you need little a, little c, and capital B, two sides and the included angle. If you want c, you need the other two sides and their included angle. Does that make sense? All right, so that's what you look for. See, you'll be fine today because we're doing cosine rule. But next week, it's all going to be mixed up, and you have to know when to use sine rule and cosine rule. All right? So, if you have two sides and an angle in between, it's pretty much cosine rule all the way if you're finding a side. All right? No. Okay? So what I'm going to do now, that is to find side lengths. This is to find side lengths. So if you want to find side lengths, there's three different sides you could find. They're the formulas. Okay? But if you want to find angles, cos A or cos B or cos C have to be the subject of the formula. So what I'm going to do, I'm going to rearrange the first one. So, to find an angle, so next bit, that's to find a side. So girls, there are two ways you can use the cosine rule. Number one is to find the third side. And if you want the third side, you have to be given the other two sides and the included angle. But to find an angle using the cosine rule, you must need the three other sides. You need all three sides of the triangle. So to find an angle using the cosine rule, you need all three sides of your triangle. Now, I'll show you why. What we're going to do, we're going to rearrange the side rule that we just looked at. Okay? So I'm going to take this and I'm going to make cos of A the subject of the formula. So, all of these terms are separated by plus and minus signs. Let's take the minus 2bc, pick it up and take it over to the other side. What do you get? Plus 2bc cos A. Let's keep the b squared and the c squared over here, and let's take the a squared over minus a squared. We're nearly done. So what I've done, minus 2bc cos A, see we're adding and subtracting things from both sides. Just pick this up and take it over, it becomes plus 2bc. This is a positive a squared, take it over to the other side, it's a minus a squared. Now how do I make cos of A the subject? 2bc, is that plus cos A minus times or divide? It's times, so divide by 2bc. And that's the formula. That is the formula to find an angle. Cos of A is b squared plus c squared minus a squared over 2bc. That's the formula for cos of A. Now, I'm going to draw a triangle here again. Capital A, capital B, capital C. And little a, little b, little c. You know why I'm putting little a, little b, little c where they are? Opposite. Little a is opposite capital A. Notice if you want capital A, so if you want capital A, notice you're adding b squared and c squared and you're subtracting the one opposite the A, the capital A, over the BC, the 2BC. So if you want capital A, cos of capital A, remember this does cos of capital A. You're going to get a number, then you're going to have to go shift cos in the end, all right? And the first rule did a squared, b squared, or c squared, so you're going to have to square root your answer. But we'll do that when we come up to it. We're just learning the formulas for now. So let's rewrite the formulas for what you think cos of b is. Notice if it's cos of A, it's minus a squared. Got it? And you're adding the other two, and the other two are on the denominator as well. All right? So follow the pattern. This is just about following a pattern. We will give you one rule. You have to know how to write the other one down. So cos of capital B would be, the rule tells me don't add the a squared. That's one you want to subtract for the first one. When you're finding a, you subtract the a squared. All right? Amazing. Look up here. When you wanted the a squared, you're adding the other two and subtracting that big cos A. All right? So let's go. Cos of B is, what do I write? A squared plus c squared minus b squared. And what is it over? The ones that are the plus ones, 2ac. The cos of C formula would be, don't add the c. Which ones do you add? a squared plus b squared minus c squared over the positive ones, 2ab. Okay? So with this rule, the one that you want, it's always the one that you're subtracting. Its opposite angle is the one that gets subtracted. So let's look at this. If I want cos of A, what am I doing? I'm going b squared plus c squared minus a squared. So if I want cos of A, I'm doing the 2 next to it, b squared plus c squared minus a squared over 2 times b times c. If I want cos of B, what am I doing? I'm adding the 2 next to it, the capital B. A squared plus c squared, but subtracting the one opposite it, over 2 times ac. If I want c, how am I finding it? I'm going cos of c is a squared plus b squared minus the one opposite, c squared, over 2ab. Notice, if you want an angle, you need all 3 sides. How do we know that? Because on the right-hand side of the formula is little a, little b, little c. So to use this formula, you need little a, little b, little c. They're all sides because they're lowercase. Do you get it? So if you want to find an angle using cosine rule, you need 3 sides. You can tell. I want the capital A angle, I need 3 sides. Look over here. If you want the side, I need an A and a B, which are 2 sides, and an angle. But the angle's got to be between the other two, because if I drew this out, for example, C, angle C is between A and B. Angle A is between B and C, and angle B happens to be between little a, little c. Got the idea? All right. Now, they are the formulas. Now we do some examples. So they want you to find the missing side length. So I'm just going to put find x. So in this question, they want you to find the missing side length. Now, you know how we've learnt about sine rule? You could never use the sine rule here because, look, I've got a pair, but do you know any other angles to make up other pairs? So we can't use the sine rule. But notice you've got 2 sides and the included angle. So please put that down. Note, I have 2 sides and the included angle. So that's how you look for cosine rule. If you have 2 sides and the included angle, it's always cosine rule. All right? I've got 2 sides and the angle in between. That tells me cosine rule. How do you know that it's not sine rule? You look for opposites. Yeah, I've got 1 pair, which is incomplete, but I don't have another full set of crisscross, so you can't use sine rule. All right? So you've got 2 sides and the included angle. That tells you cosine rule. So girls, I'll just write any version of the cosine rule. It doesn't matter. A squared equals b squared plus c squared minus 2bc. Remember, it's the other 2. If you want this one, you add the other 2 minus 2 times that times the cos of the opposite angle. Now, if you want, ladies, you can label the one that you want with the a, little a, if it's going to help you. So you'll be given one version of the formula. Whatever you're given, see, I don't use the formula. Once you learn it, you won't use it. But at the moment, if you want A, that's going to be the one you want. You'll call this little a. So if that's little a, what's this? Capital A. Where's B and C, and doesn't matter which one's which? It doesn't matter which one's which. I'll call this B and I'll call this C. Let's go. A squared is x squared equals, what's B squared? 7 squared plus 8 squared minus 2 times 7 times 8 times the cos. So girls, this is how you do it. The one that you want is the other 2 squared. 7 squared plus 8 squared minus 2 times those 2 times the cos of the angle in between those 2 times the cos of 72. So now you work out the right-hand side in one go on your calculator. 7 squared plus 8 squared, so you can go 49 plus 64 minus 2 times 7 times 8 times cos 72 equals, that's x squared. There is no way you're going to get a triangle with 7, 8 and 150, or whatever it might be that you're going to get. What are you getting? Let's just give me the answer for x squared. So we're getting 78.39. I'm just putting dot, 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 meaning that it continues. That's what x squared is. Girls, you could never close the triangle if you had 7, 8, and 78. Your triangle won't close. So x is the square root of that. Please don't give a rounded off answer there. Please don't clear your calculator. You just go square root, answer, equals. Got it? What do you get? 8 points, etc. Dot, dot, dot. Therefore, x is approximately equal to, I'm just going to go one decimal place, 8.9 to 1 dp. Okay. Next one, you want the angle. Now, I don't know which version of the formula. Let's go cos of capital A equals. So I'm going to call this one capital A, therefore this is little a, that's little b, that's little c. Do you remember the formula? Do we add the a or add the other two? So cos of A is b squared plus c squared. It's always minus a squared over 2bc. That's the rule for finding an angle. So I've always labelled the one you want. If you're going to use the a squared versions of the formula, call what you want capital A. All right. So the one I want, I don't add the one opposite ever. So this is 4, that's 6, this is 8. Just by looking at the numbers 4, 6, 8, which one do you think is going to be the biggest angle in the triangle? Opposite the 4, opposite the 6, or opposite the 8? Okay, good. Because sometimes they ask you to find the smallest angle in the triangle, or they'll ask you to find the largest angle in the triangle. You're not going to hit and miss and find 3 of them, are you? Because the exam will be over by the time you finish the question. If I'm asking you for the biggest angle is opposite biggest side. Smallest angle is opposite smallest side. Okay, let's go. Cos of capital A equals, what have I got? 4 squared plus 6 squared minus, notice I'm always subtracting the opposite one to what I want, minus 8 squared over 2 times 4 times 6. Now, cos of A equals, you need to work this out as an entire, as a decimal. You're going to end up with a decimal between -1 and 1, depending on whether it's an obtuse angle or not. So, please evaluate the whole of the top row before dividing by the denominator. What does the denominator equal anyway? What does the denominator here equal? What's 2 times 4 times 6? Right. So do the top row equals, just divide it by 48. Otherwise, you do all of top row equals divided by brackets for the denominator. You have to use brackets on the denominator. What do you get? Sorry? 25 dot dot dot, whatever it is. So therefore, A is shift cos negative 0.25, which is degrees. Now that's a decimal. You haven't given me degrees in minutes, so it's still out of 100, your decimal bit. You understand what I'm saying? Is 47, is 4 more or less than halfway? So give me to the nearest degree. 104, and if you want to be sure, you can go shift DMS and you'll see that it's less than 30 seconds. So therefore, 104 degrees to the nearest minute. Now, until you get my next video, can you please just I'll make you do all of question 3 and 4 for practice tonight. You'll be getting another video on problems.